Hi everybody. I thought we would have a quick review of solving equations. So solving equations involves finding values for unknowns that make an equation true. Sometimes they can be called finding roots when we're looking to find when an equation equals 0. And initially we introduced this through the balancing method. So if we have an unknown a and a plus 5 equals 10, we can rearrange that equation by subtracting 5 from both sides and discover that a equals 5. If we resubstitute 5 back into the equation, 5 plus 5 we find equals 10. And there's a squillion different examples that we've done rearranging linear equations to find unknowns. When we're doing quadratics, the first time we look at solving equations probably is with Null Factor Law, where we discover that a times b where a times b equals 0, either a or b or both have to be 0. So if we had an equation like 2xy, which isn't a quadratic, but it will demonstrate null factor law easily enough. For 2xy to equal 0, either x would have to be 0, or y would have to be 0, or both would have to be 0. 2 times 0 times any number is still going to be 0. 2 times any number times 0 is going to be 0. Either x or y could be 0. We can then expand that into factorization techniques in quadratics and use it to solve equations to find unknowns that make the equation true. If we had x squared plus x equals 0, we could factorize out the x and we'll end up with x times x plus 1. Now in this case we have an expression times by another expression equaling 0, so we can use null factor law. We're going to let a equal x and b equal x take 1. For x to be 0, well, x would have to be 0. For x plus 1 to be 0, x would have to be negative 1. And if we resubstitute those back into the original equation, we'll find that both 0 and negative 1 will result in an answer of 0 as required by our original equation. Once we've seen that for simple factorization, we can expand that to our trinomial factorization. If we had an expression x squared plus 4x plus 3, we could factorize that to x plus 3, x plus 1, letting x plus 3 be a and x plus 1 being b, to make this a expression 0, x would have to be negative 3, negative 3 plus 3 would be 0, negative 3 plus 2 would be negative 2, but 0 times negative 2 would still be 0. And for the second one, x would have to be negative 1. Negative 1 plus 1 would be 0. 0 times whatever this is would again make 0. If we substitute these values that we've found back into our original equation, we'll find that it's a solution that makes this 0. So negative 3 squared, this part, plus 4 times negative 3, this part, plus 3, is 9 take 12 plus 3, is in fact 0 as required. Similarly, if we let x equal negative 1 and substitute it into this equation, negative 1 squared plus 4 times negative 1 plus 3, again, equals 0. Now if we were just to try and play guess and check with this equation, that could take us some time till we found an example for x that worked, whereas by factorizing we can find the solutions for this equation where values for x that make this 0, that have a solution of 0, quite easily. Here's another example. This time we're going to take out a common factor first. So the common factor of our three terms is x, leaves us with x squared plus x takes 6. And then if we factorize our trinomial inside the bracket, we get x plus 3 x take 2. Now we have 3 terms, but null factor law can be expanded to include 3 terms. As long as one of them, 2 of them, or 3 of them are 0, we're going to get a solution. So in the case of the first part of the expression, x would be 0. In the case of the b part of the expression, x would be negative 3 to make this bracket 0. And in this part of the expression, x would be 2. So if any of those, if x is 0, if x is negative 3, or x is 2, it will make this original equation here 0. Which is not evident just by looking at it. But we can show it. Stick 0 into this equation, we get 0. Stick -3 into this equation, and guess what? We get 0. And similarly, x equals 1. I don't think x equals 1 will work, but I'm pretty sure x equals 2 will. Let's stick a 2 in here. Stick 2 into this equation, and similarly we'll get 0. If we stick any other value in there, we will not get 0, and that statement will not be true. Now, if factorization techniques are not practical, we can of course use the quadratic formula because it does the same job. So if we have this equation here, x squared plus 4x takes 7 equals 0, that doesn't factorize easily, so we'll let a equal 1, b equal 4, and c equal -7 and substitute it into the quadratic formula. And if we do some algebra, we'll eventually get to -2 plus or minus root 11. And we think to ourselves, well, how do we use that? Well, we can either take a decimal representation, which I've got 2 decimal approximations here for -2 plus 11 and -2 take 11, what's indicated by this equation. But more accurately, we could just put these values back into the equation. So -2 plus root 11 squared plus 4 times -2 plus root 11 takes 7. And if you stick that into a calculator, lo and behold, it will equal 0. And there is no way you could use guess and check to figure that out. Quadratic formula really is the only practical solution. And similarly for -2 take root 11, stick that into the original equation, this thing here, and we will get, again, 0 as our answer. Now, if we have an equation in turning point form, we can rearrange the equation and solve it. And that's another way of solving quadratic equations. So add 4 to both sides, take the square root of both sides, take 3 from both sides, we get left with this equation here. Now normally we would have a root over here, but because 4 is a square number, root 4 just gives us 2, which gives us 2 very neat solutions. -3 plus 2 will give us -1, and -3 take 2 will give us -5. And if we substitute these values back into this equation here, -3 plus 3 will give us 2, 2 squared is 4, 4 take 4 is 0, and similarly -5 plus 3 will give us -2, -2 squared is 4, 4 take 4 also gives us 0. No other value for x will make 0 with this equation. Now, that's all well and good, but occasionally you'll get an equation that doesn't have 0 on the right-hand side, but we can just arrange it to make that so. So in the case of x squared plus 7x equals -12, we'll add 12 to both sides. That way we'll get 0 on one side of the equation and a nice trinomial on the other side. And this is a factorizable trinomial, x plus 3, x plus 4. Our solutions for the equation would be x equals -3 and x equals -4, which is not initially obvious just by looking at this equation that you can use this method, but we can show that it works. If we take x squared plus 7x equals -12 and substitute in -3, which was one of our solutions, -3 squared plus 7 times -3 is actually equal to -12 as required by the equation. And similarly for x equals -4. So there's a bit of a rundown of techniques you can use to solve, well, a little bit on linear, but lots on quadratics. I hope that helps everyone, and I'll speak to you all soon. Thank you.